Hi. For our senior design project, we decided to do a self-loading hay trailer. Ethan Myers was responsible for drafting. Scotto Rodriguez is responsible for funding. Taylor B is responsible. He's the team manager. Cole Tinsley, that's myself, is responsible for research.
So a little bit about that background. So initially the project was started for me. Ever since I initially started doing mechanical engineering, it was my idea to, design my own agricultural equipment one day. And so I decided to take this to the next level, and we're trying to do this for our own senior design project. And essentially, our design is to implement a self-loading hay trailer where it can be universal for farmers in various different types of quality feeds, whether you're moving large square bales, small square bales, or round bales. Currently, for this design, for our senior design, we want to make sure that our project focuses on strictly small 60-pound square bales, where many farmers in all categories, whether it's professional ag or hobby street farmers, mainly do small squares. So the existing bale picking up machines are currently inefficient and requires multiple steps from field to road. This creates downtime on farmers, and some of the machines that are available for farmers to purchase that are self-loading wagons are extremely expensive. Like New Holland, they have a hay stack cruiser machine. It's $250,000, and it's only a machine with the trailer combined. You can't break apart the trailer itself and use it onto a semi, which is what we're trying to implement. So you have an expensive asset that can only do one task at the farm, which is just moving little square bells, and the machine itself is combined together. What we're trying to aim, we're trying to reduce the processing steps such as unloading, reloading, and securing hay for transport. So by us creating a self propelled hay loading trailer, this eliminates all these issues that farmers run into, because time is money, and processing is the number one priority in between each cutting on the farms, because farmers live in various areas where they're dependent on getting their crops in before weather hits, and there's certain moisture contents that need to be hit. Our focus is to design a trailer that can efficiently pick and transport hay bales without needing additional equipment. So, in addition to this, we want our hay trailer to be multi-use, so you can use it for the various uh, hay qualities, like large squares, small squares, round bills. And the beauty about this trailer is we can have it connect onto a semi, or we can have it connect onto the back of a tractor. And if you're running it off of a semi, you can use the wet kit to run it hydraulically. And if you're using it on the back of a machine, you can have like a towable. An automated hay. So the project is an automated hay trailer, loads small 60-pound square bells, like I was stating earlier, and it's able to load itself onto the trailer, and it's fully road legal. Uh, Large scale trailer to be developed alongside smaller functional prototypes. Because in addition to the other trailers that are on market currently, they only focus on one type of hay quality. So, for instance, they only have a trailer that just moves large square bales. There's only a trailer that moves round bales. There's only a trailer that moves small square bales. So we want to be able to have attachments that's multi-use, and our trailer be able to be multi-use in the future. And in this image, as you can see on the slides, is our CAD design that Ethan created for us. It's a semi trailer, and you can see the arm on there that comes out and would pick up the bales. And the next slide goes to Taylor B.
Hey, looking at the need for why we're actually doing this, really is kind of coming down to a few reasons. One of them is to kind of automate farming and to kind of reduce the need of additional equipment and extra like running equipment like tractors and trucks and stuff like that. Really it's kind of consolidate the equipment into one specific piece of equipment that could be used for essentially the whole operation from beginning to start. This also is going to help with the rise in labor costs, and just kind of the rising expenses and everything in land and just as crops and more like utilities and stuff cost to raise those crops from seed up to actually being able to harvest. And this will also be able to help drive high yields for smaller and non-industrial farms. Similarly, looking at the market, um, currently, we've already talked to a few of our customers or a few potential customers. One of them being one of our own group members, his own company, Scotto's Custom Harvesting. We've already talked to them about what are they looking at in a project, like what are they looking at in a trailer, and specifically what kind of things would make it attractive for them to purchase. So we've already spoke to some of our local market, but also looking at some of like some studies that been performing. The hay market is slowly steadying rising. Maybe not so much in America, but globally wise, it's a growing commodity, and it's always going to be in demand, especially overseas in like China and Japan and other Asian countries. And so as far as how we're going to get funding for this, we have two real methods kind of coming at us. One of them, I was mentioned as before, was our own group member, Scotto's Custom Harvesting. Once we kind of get a design and a prototype finalized and we start making like an actual viable, usable product, they will most likely be our first customers. But outside of actually customers, we look at getting funding from like fundraising and from supporting and sponsors through other like local agriculture companies. So local John Deere dealers, local case dealers, various agricultural outfits, just locally around our places that want to support another local startup, I guess, with some teens and some people from the local area. The other way is from Scotto's Custom Harvesting. As mentioned earlier, once we get one finalized, a design made, and actually in our hands, a tangible thing, they would most likely be our first customer. Now, potential designs, Ethan.
Hello, everyone. Kind of have to stand back a bit because I'm so tall. All right, so when we first started coming up with this, we went through like maybe 3 or 4 different ways to do this. The existing methodology of moving these small hay bales into a trailer is the Anderson bale wagon, which is up in the upper right corner of the image on this slide. So that is just an arm. It lifts the thing up and it drops it behind it, and then it pushes it back with a hydraulic piston. There's also the Keith walking floor idea, which is we would use the same arm system, throw it in, and then the floor itself would just kind of shuffle back and forth and use the differing friction to like kind of slowly vibrate the hay backwards. Cole came up with a piston idea, which I commented was reminiscent of Minecraft, but it was actually kind of ingenious. That is at the top left corner. That's his drawing. There's also what we have now, which is we're going to use a roller intake instead of an arm, because after looking at the arms that self-loading logging trucks use, it's very slow and tedious and has a high probability for error. And if you miss a bale, you got to stop the whole rig and move backwards, and it's just a whole mess. So instead, we'll just use a roller intake, which is a little less versatile, but is a lot faster. And that was mainly, I like to say that was because of my research into arms, but it was because Scotto told us we needed something faster, and so that's what we did. So next slide. Okay, so kind of coming into what we have now. For the full-size trailer as it stands, we had a robotic arm. It's going to get switched out for a roller intake. This arm system would have had a counterweight, and that will be transferred over to the intake system. So on the farmer or whatever, to reduce weight on the user or the system, instead of fighting gravity every time to like lean over the edge of the truck, we're going to have a big spring system or some other counterweight, so that if something breaks, or when we're unloading, we're reloading the thing, the farmer doesn't have to like move 300 pounds of steel, the arm or whatever contraption we end up with to get the thing on the trailer. It will just be the weight of the hay bale essentially, because a spring or a counterweight or something will lift it up, and that will be transferred over to the roller intake system that we're looking at now. Now, once it gets onto the trailer, it's a little bit more complicated. So we're going to make these like big stacks of hay vertically, and then there's going to be a dump system. So it like lifts up and then just slides back all together. So I'll make a big vertical stack, maybe like 6x6. So six small bales by 6 small bales, stack them up, lift up, and then they roll back. The current dump truck system doesn't use rollers or anything. It's just a piece of tubing underneath each of them, maybe with some like some sort of biolubricant that's safe for consumption for animals if it gets onto the hay. The dump truck will run on the dump truck portion will run on hydraulics, so like a normal dump truck. But to actually get from the arm or the roller intake into these like stacks that we're going to drop back, we're working on a gravity sorting system that involves linear actuators. So you'll fill up like the top row, and then they'll drop, and then they'll fill up the top row again, and they'll drop. And in between each of these like hay columns is a piece of sheet metal so that they don't like catch on each other and like fall in sideways or whatever. So handing off to Cole for our conclusion now.
Overall, our purpose here is to build a self-loading hay trailer that's suitable for 60-pound beds. The objective is more suited toward any farming operation really that uses that kind of bale. And we're trying to fulfill the consolidating farming market to fill a growing hay export industry. Evolution of designs from arm and walking floor to elevator and dump bed is something that we think is essential because it improves the efficiency of the overall production in the system. That's all we've got.